All right, guys and gals, on our next installment here for the 7th, 8th grade geometry unit, we're going to be looking at what we call basic angle relations. So a lot of this stuff you should have covered in 7th grade, maybe even 6th grade, depending on your teacher or where you went to school if you didn't go to our school. But we're going to go through all of these. If you know them, great, then just jot down the name, give yourself an example. If you don't know, then definitely write down the definition with it as well. Today's going to be a lot of vocabulary. So without further ado, let's get started. First, just some real quick issues when we're talking about geometry. We make geometry with various elements, all right? Those are points, lines, and segments. All right. So real quick, let's talk about those. Points are simply locations. Right? And we represent those locations as a dot. So for example, that's a point. And we name all of our points with capital letters. So for example, we could talk about point A. Lines, all right, as the name would suggest, is that straight path from point to point. Ran out of space there. So for example, we could have one point here, maybe one point here. We play connect the dots. We always put arrows on our lines because they extend in both directions, and it takes at least 2 points to make a line. So for example, this could be point B, and this could be point C. We can name lines by the points that are on there. So for example, we could name this line. This is the symbol for line. We could name it line BC. We could also name it line CB. Order doesn't matter. And then, of course, we could also name the line by a lowercase letter. So for example, maybe I call this line and we'll use a lowercase a. So we could talk about line A as well. Segments are simply the straight paths between points that don't continue on in opposite directions. So in other words, they're finite paths between points. So for example, I could talk about a segment, let's draw one in here, X, Y. And the symbol for that is just a bar, no arrows. And we could talk about segment XY, or we could talk about segment YX. Again, the order, so to speak, does not matter. Okay? So again, those are some of the basic things that we'll see. And in different examples, you'll see this notation. I just wanted you to be clear and that you knew how that worked. So let's get into the actual angle relationships. So let's talk about an angle. Okay, an angle is formed by either two lines, two segments, two rays. And what we're looking at with an angle, we'll do our example over here because we're going to talk about all kinds of different angles here in a minute. For example, maybe my angle is made up of rays. All right, a ray is kind of like a line and a segment combined. It has a definite endpoint, then extends out infinitely in the other direction. So here's an angle. It takes 3 points to name an angle. So for example, we could have point A, point B, and point C. All right. And when we name that, the symbol that we use looks like this. It's kind of like a less than symbol that's been turned a little bit. So we could talk about angle A, B, C. And notice B is what we call the vertex. In other words, it's where our segments or our rays or our lines, whatever, where it meets up and forms that point. We call it the vertex. The vertex is always in the middle. So I could also name this angle CBA. Again, notice C to B to A, that defines that angle there. Now, we have the interior space. And so that would be, say, between our segments or between our rays. And then we also have the exterior, which would obviously be the outside of our angle. Our angles we measure in degrees. As you get further along in math, you'll change to what's known as a radian, but we won't deal with those this year. And our degrees, for our purposes, as we measure an angle, run from 0 degrees all the way up to 180 degrees. Now, obviously, you could have angles that go broader than that because we could go a full circle, which is 360. But for our purposes, our angles will measure anywhere from 0 to 180. So, for example, this angle is, I don't know, if I were eyeballing it, I'd say maybe it's 20 degrees. I'm just taking a guess there. It's a rough sketch. So let's talk about some different types of angles. All right. So we have what are known as acute angles, and these are angles that measure less than 90 degrees. So if we're looking for an example of that, maybe we've got an angle that looks like this. Okay, so a nice acute angle there. Kind of separate those out. We can also have what we call right angles. And these are angles that measure exactly 90 degrees. And right angle we should be familiar with because we've been dealing with this with right triangles. Kind of like the corner of a piece of paper. If I can get my paper up there. There we go. Like that. What we do with right angles is we put this little box in here typically to denote that that is indeed a right angle, especially if you've got a teacher like me who can't draw a right angle to save his life. So again, they measure exactly 90 degrees. And then, of course, we've got obtuse angles, and these measure greater than 90, but less than 180. All right. So an example of an obtuse angle could look something like this. So clearly more open than 90, but clearly not 180. And let's talk about what we call those angles that are 180. We call them, make sure you can see this here, we call those straight angles. And these are angles that measure exactly 180 degrees. And those straight angles will look something like that. You'll have, say, a point here in the middle for our vertex, though it's not much of a vertex. And then, of course, your other points out like this. All right. And your others up here, obviously, we could have a point maybe here, here, and here. And I'm not going to bother naming these. We're not using them for any particular purpose. But I will draw them in just to show you that we've got those points. And then if we wanted to name them, we could. All right. So that takes care of our angles. In terms of the types, let's label that. We'll say types of angle. So we've got acute, right, obtuse, and straight. Let's talk about what we can do with some of these angles, some of the relationships that exist there. Excuse me. Let's see here. One of them that you should know or be familiar with are complementary angles. All right. These are angles whose sum is 90 degrees. So for example, if I had an angle here, I don't know, we'll draw it kind of small. Maybe it's 50 degrees. And then I've got another angle here, maybe just a little bit smaller, and it's 40 degrees. All right, if I take 50 degrees and add it to 40 degrees, obviously we would get 90 degrees. Okay, complementary angles don't have to be side by side. Sometimes you'll see images like this where it's a right angle that's been cut apart. So maybe you've got a 20 degree angle here and a 70 degree angle there. So 20 degrees added to 70 degrees is, of course, still 90. But again, complementary angles don't have to be side by side like this. They can, but they don't have to be. A lot of times they'll be separate from each other. As long as they add up to 90, they're considered complements. Let's talk about another set of angles you should be familiar with, and that is supplementary. And these are angles whose sum is 180 degrees. So for example, maybe we've got an angle like this, and maybe it's 130 degrees. And then we got an angle maybe, I don't know, like that. And it is 50 degrees. And then obviously 130 degrees added to 50 degrees is 180 degrees. And again, just like complementary angles, supplements can be side by side. So for example, maybe you got a couple angles here on a straight angle, and maybe you've got 60 degrees and I don't know, 120 degrees like that. So obviously 120 added to 60 is still 180. But again, they don't have to be side by side like this. They can, but again, typically they'll be apart. But again, those that are together. And let's talk about what angles are that are together. Let's go ahead and address that. We call those angles, here we go. We call those angles adjacent angles. And these are angles that share a common side, a common vertex, and have their own space. So for example, a set of adjacent angles could look like this. Right? Notice here's the common side that they share, and I'm going to name these angles. Sometimes we can name angles like this by points. Sometimes we can name them like this. We can call them, say, angle 1 and angle 2. Sometimes we'll name them that way. So if angle 1, notice here's the side that it shares with angle 2. Here's the common vertex that they share. And notice angle 1's space, its interior, is completely separate from angle 2's interior. So those are adjacent. Some angles that maybe aren't adjacent. Let's take a look at that. Here's what we'll call a non-example. So here's angle 1, here's angle 2. So notice they each have their own space, right? They each share a common side, but notice angle 1's vertex is here, but angle 2's vertex is there. So not adjacent. So again, adjacent, you have to have the same vertex, a common side there, and then of course your own individual space in order to be considered adjacent. All right. Oh, let's see, there's one more angle relationship, and I've run out of space here. Let's flip to the back. We call these this relationship a linear pair. All right. And a linear pair are adjacent angles that make a straight angle. For example, here's angle 1, here's angle 2. These angles are what we call a linear pair. Again, line, notice that word line is in the word linear. Here's our line, a pair, of course, meaning 2. So there are our 2 angles that help create this line, right? Angles rather, that are a linear pair are also supplementary. Right? If I were to add angle 1 and angle 2 together, whatever they're worth, we should get 180 degrees. So kind of keep that in mind. Right? A couple more issues we need to talk about. Let's see, where are we at in the grand scheme of things? Vertical angles. This one is super, super important. As a matter of fact, it's so important, I'm going to switch colors. Put a star by this one, folks. Super, super important. You're going to use that this year. You might use it next year in algebra if they get into any geometry stuff, but you'll definitely use vertical angles when you get to geometry class in high school. Very, very important angle relationship. Vertical angles, all right, they form when 2 lines or segments cross and the angles opposite are called vertical. So take a look. And I'm going to switch colors because I'm tired of looking at blue. Let's draw two lines in. So maybe there's a line here. Maybe there's a line here. That's pretty. So when two lines cross, the angles that are opposite each other, so in other words, non-adjacent. So if I've got angle 1 up here, angle 2 down here are vertical. So I could say angles 1 and 2 are vertical. Okay. I could also, let's change colors again. I also have angles 3 and 4. Angles 3 and 4 are considered vertical. So in this case, by vertical, we don't mean something like this that's straight up and down. That's not what we mean. What we're talking about are angles that are opposite each other. So we call them vertical angles. Now notice, take a look at 3 and 4 for a moment. Take a look at 1 and 2 for a moment. Hopefully you realize that angles 1 and 2 are exactly the same size. Angles 3 and 4 are exactly the same size. Okay, but how do we know that? Well, take a look. I'm going to turn the page here just a bit. We're going to cover up 2 and 4 for a moment and look at what you've got. Angle 3 and angle 1 are a linear pair, right? Notice they form a straight line. That means these add up to make 180 degrees, right? Keep that in mind. Let's turn the page, cover this up. Angles 1 and 4 are a linear pair. Notice they make a straight line. That means they add up to 180 degrees. So if angle 1 plus angle 4 makes 180 degrees, and if angle 3 and angle 1 add up to 180 degrees, well, the only way that works is if 3 and 4 are the same. And notice we could do that same trick for angles 1 and 2. So one thing we can say about this is that, let's use the shorthand version here, angle sign. So angle 1 is congruent to angle 2. And in this case, angle 3 is congruent to angle 4. This symbol is congruent. It looks like this. It's an equal sign with what's called a tilde above it. I call it a squiggle. I think that's a more technical term. But that means congruent to. Congruent is kind of like an equal sign. You know, for example, numbers can be equal. For example, something like 10 is equal to 2 added to 8, meaning that these two value-wise are the same. Congruence has a similar meaning, but when it comes to shape. So for example, if we talk about our hands, most people's hands are congruent. And what we mean by that is that if I take my right hand, for example, I can take my left hand, place it on top, and they match. All right, there's no gaps, no overlaps. Everything matches up. Okay, and again, not true for everybody, but for most of us, they're congruent. In other words, they're the same size, they're the same shape. If I put them together, they match up perfectly. So if I were to cut angle 2 out of this piece of paper and cut angle 1 out from this piece of paper, they would lay one atop the other and they would match up perfectly. So that's what we mean by congruent. We could also say that whatever their measures are equal. So let's write that out. To write measure in a shorthand fashion, we use m. So the measure of angle 1 is equal to the measure of angle 2. So for example, if angle 1 was, say, 110 degrees, then that means angle 2 is also 110 degrees. And notice we use equality when we're talking about number. So if I say measure of angle 1, I'm talking about what it's worth. So again, if it's 110 degrees, wonderful, then angle 2 is also worth 110 degrees. We could say the same thing about the measure of angle 3 being equal to the measure of angle 4. So if this were, say, 70 degrees, then that means angle 4 was also 70 degrees. Oh, I'm running out of space. For my purposes, I'm going to mark that off and just keep going here because I don't have any questions. You might, but again, if you've got questions, make sure you write them down. But I don't have questions, so we're going to skip that section. And I'm going to keep going. So we have two other things we need to talk about briefly, and you should be familiar with these. Not so much angle relationships, but they'll cause some interesting things with angles. These are what we'll call line relations. All right. The first one we'll talk about is perpendicular lines. All right. And perpendicular lines are lines or segments, but they're lines that form right angles. Angles. For example, I could have a line coming down like this and a line coming across like this. Put our little arrows on there, and we'll put our right angle mark. Cool. So these lines are said to be perpendicular. So let's give them names. Let's see here. Let's call this A. We'll call this B. Maybe over here we'll have X. Maybe over here we'll have Y. I don't know. It doesn't really matter their names. So I've got line AB. The way we can write perpendicular in a shorthand format is we could talk about line AB. The symbol for perpendicular to is an upside down T. So this would read line AB is perpendicular to line XY. In other words, these two lines intersect and they form a right angle. As a matter of fact, they form multiple right angles. In this case, I've got 1, 2, 3, 4 right angles. And again, I could prove that pretty quickly. Notice if this is 90 degrees, notice we've got a linear pair. Linear pairs, as we said, are supplementary. So if this is 90 degrees, then that means this angle over here also has to be 90 degrees. And then we could continue that same line of reasoning. We've got another linear pair. If this is 90 degrees, then that has to be 90 degrees, and so on. The other that we need to talk about, and I guess we'll do it in a different color to kind of offset it here, are what we call parallel lines. Okay. And these are lines that never intersect and are on the same plane. Now, what do we mean by plane? By plane, we mean flat surface, all right? So for example, I'm writing on my desk right now, but the wall in front of me is a different flat surface. So the wall is a plane, my desk is a plane, all right? So parallel lines have to be on the same flat surface. So for example, if there was a line here on my desk, but another line may be running up and down on the wall, those aren't parallel, all right? Even though they don't touch each other, they're not parallel. So let's draw parallel lines. They look something like this, and they don't have to be slanted. Let's draw a different set. We'll do it in green. Maybe we've got another set of parallel lines over here. And typically when we see parallel lines, unless a set of directions tell us they're parallel, a lot of times you'll see a symbol looking like this. Kind of looks like a triangle or an arrow that's extra on the line. And that indicates that, hey, these two lines are indeed parallel. Let's talk about the symbol. We'll get our lines drawn up. Maybe this is line BC. This is line, I don't know, maybe DE. The symbol for parallel is as follows. Take a look. We can talk about line BC is parallel. So it's kind of like an equal sign turned upside down. And it tends to run a little longer than an equal sign. So line BC is parallel to line DE. Parallel to, perpendicular to. Now you may be thinking, I get this with angle relations, because notice we get right angles, but Mr. Lamar, there are no angles here, right? Except the straight angles that make up the lines. So what? Who cares? Well, our next lesson is going to deal specifically with parallel lines. And take a look. If I have parallel lines and I drop another line across them, suddenly all these other angles form and all kinds of neat things will happen. But again, that's something we'll talk about another day. Make certain, guys and gals, that you've taken good notes. If you need to go back and rewatch any of this or get any of these diagrams drawn, go ahead and do that. But these are things that you're going to need to know. And when we have class next, I'm going to assume that you are at least familiar with all of these words. I'm not going to give you some sort of vocabulary test. But when I say things like obtuse angles, or if I say adjacent angles, I'm going to assume that you know what I'm talking about. So if you need to review this before class, if you need to make certain that you've got all your notes complete, please do that. Again, this part of the unit is going to be a lot of vocabulary, and you've got to know all these terms. Make sure you bring your questions with you to class, and I'll be happy to help you out. Have a great day, guys and gals.